We start the first session, which is technical session 1, with a talk on the root DNS servers. It covers root DNS in detail, and before we start with the talk, I'm very curious to do a survey. How many people in the audience have run a DNS server before or are operating a DNS server? Can you raise hand? That's quite a lot of people, David, who have not operated, so it gives you a good time to explain what root servers are and the whole thing. All right, to David.
Thank you, Good morning, everybody. Good morning. There we go. Good morning. I'd like to thank the program committee very much for allowing me the privilege of speaking this morning here at INNOG. Good morning. I hope you're all awake. I'd like to talk to you today about root service. And in our discussion, I'd like to just give a brief history of how we got to where we are today in the root server system. And after this history, we want to talk about root service here in India. We will describe a little bit about the current state of root service in India and some of the places where perhaps we should go in the future. After that, we'll talk a little bit about governance and some changes that are happening at the root of the structure of the root server system. And then we're going to talk a little bit about how the root zone is distributed. So to begin this morning, let's talk a little bit about the brief history of the root server system. The DNS specification was first published in November 1983 when a gentleman named Paul Makapetris published RFC 882. The hierarchy Paul envisioned required a server to function as the root of this tree. And in 1984, Paul set up the very first root server. He did so at the University of Southern California's Information Sciences Institute, ISI. And in 1985, we expanded from 1 root server to 4 root servers. There were 2 at ISI in California in the United States, and there were 2 on the United States East Coast, 1 at SRI in Washington, D.C., and another at the United States, the Army's, at their Ballistic Research Laboratory in Aberdeen, Maryland. And by 1987, we had moved up to 7 root servers. But if you notice, all of these organizations and all of these servers were in the United States. There was no geographic diversity whatsoever. In July, on the 28th of July in 1991, we finally got some geographic diversity. Our friends at the Nordic University Network in Sweden, Nord-2net, were the first international root server instance. Nord-2net was operating an international wide area network with lots of protocols. It had TCP/IP, X25, DECnet, NJE. The staff operating Nord-2net had a lot of experience running DNS servers with the .SE TLD, and they were a wonderful choice to then run their root server, which they still run today. From September of 1991, and then until the beginning of 1993, everything, all the data was actually centered inside the United States Department of Defense Network Information Center, the DoD-NIC. And in the beginning of 1993, 2 gentlemen, John Postel and a gentleman named Mark Costers, transferred all of that non-military data out of the DoD-NIC into what was then called the INNOG-2, which was a central registration authority for all the domain names and all the IP addresses. INNOG took over what we now think of as a root. Later, in the summer of 1993, Paul Vixie approached John Postel, and he expressed his interest in running a root server because, as you know, Paul had created this thing called bind, and he had worked very hard on bind. So John Postel said yes, and ISC was given the 9th root server. So in 1993, we had moved to 9 root servers over 10 years, here in the internet's infancy, right? So it's 1995, and when a DNS resolver boots up, it has to initialize its cache with what we call a priming query. And the priming response that the resolver receives includes both a current name server resource record set and the IP addresses that it needs in order to reach the root servers. But in 1995, the root server names were not standardized. So the query, the response to the priming query was completely maxed out in the number of bytes that could fit into the response packet. So to fix this, three gentlemen, Bill Manning, Paul Vixie, and Mark Costers, applied what we call label compression. They came up with a name, root-servers.net, and they applied it to each of the existing root servers. And with label compression applied, there was now room in the priming response for 4 more root servers. From 9, we could move up to 13. So in 1997, we reached 13 root servers, and they're labeled A through M, and that's where we are today. We have 13 root server labels. Each has an IPv4 address, and each has an IPv6 address. There are 13 root server labels, A root through M root, and they are operated by 12 root server operators. The root servers are operated on over 900 instances across the world. However, it's interesting to note, it's not just 900 servers. Each instance might have 1 server, or it might have many servers. So there are actually thousands of root servers located all across the world. When I was putting this presentation together, I wanted to see how much traffic root servers get. Because every single DNS query eventually needs to talk to the root server and get some information about the authoritative server that it needs to go to. And I figured, this must be a lot of queries. So I took a look. And I was actually able to do this because of something that was put together by ICANN's RSSAC, the Root Server System Advisory Committee. This is a group of all the 12 root server operators, and they work together to coordinate the operation of root servers. And one of the things they figured out is it would be very good if we had a common set of metrics that we could use to express traffic that we're receiving. So it turns out that every one of them publishes an FTP site where each day they update their telemetry. And from that, we can glean interesting stats. And what I was able to see on the day that I looked, I was able to see stats for 12 of the 13 root servers. Some statistics weren't available for one. And of these 12 root servers, there were 77 billion queries being received. Now, as you can see from the graph, most of the queries come over UDP, and vast majority come over IPv4. But in the red, we do note there's actually a pretty fair amount of IPv6 traffic over UDP. So there's some good mix at the root servers of IPv4 and IPv6. What we don't see is a whole lot of TCP traffic. Most of this is UDP, a nice, lightweight, easy, fast protocol for DNS. So we have 13 root server labels, and these are the organizations that currently run them. And I was curious about these over here. Because, we have 13 root servers, but we only have 12 operators. This organization, VeriSign, it runs A. It's what used to be the INTERNIC, and through some corporate mergers and stuff, A root became VeriSign. But they also run J root. And RIPE runs K, and ICANN runs L. And how does ICANN get a root server? So I asked the question. And it turns out, when label compression was applied to the root servers, and we moved from 9 to 13, what John Postel and Mark Costers did is they set up 4 more root servers, J, K, L, and M. They put 2 of them at ISI in California, and 2 of them, L and M, were with VeriSign in the east coast of the US. And when a new root server operator was ready to go and come up, they would hand out letters. So the first organization to come was RIPE, and RIPE was assigned K. And K came out of the VeriSign group of J and K. And then the next organization to ask for a root server was in the Asia Pacific region, was WIDE, which is located in Japan. And so John Postel said, hey, look, WIDE is going to get a root server, so let's give them J. J for Japan, get it? And Mark said, no. It's not for Japan, it is for Asia. It is for Asia Pacific. Oh, and by the way, I already gave one of my root servers, so why don't you give one of your root servers? So it became M for WIDE, which actually sort of harkens to WIDE's founder, Jun Murai, M. Meanwhile, LRoot was being operated by ISI. It was in the same LAN, the same topological LAN as BRoot. And it was also sitting on the floor. It was sitting on the floor in an office in California, in the same land. And a gentleman named John Crane, who works for ICANN, said, it would probably be better if we took a very important root server and maybe put it in a rack, and maybe if we separated it, put it in a different network LAN than one of the other root servers. So John sort of picked it up, and he sort of brought it to an ICANN data center and put it in a rack, and he might have renumbered it into ICANN's names, numbers, space, and now ICANN was running LRoot. Officially, ICANN running LRoot was part of ISI support of ICANN's creation. But it was always intended to be run by another operator. So let's talk about root service in India, and then we're going to come back to that narrative. So I looked last night while I was sitting in my hotel room because I wanted the most up-to-date information. And as of last night, there are 20 root server instances here in India. There are 996 total root servers around the world. 20 of them are here in India. And of those 20, they're covering 7 metropolitan areas. It should not be a surprise to anyone here to learn that Mumbai has the densest coverage of root servers in India, simply because Mumbai is where so much of the submarine cable lands, has the dense fiber connectivity. And Mumbai enjoys 7 root server instances from many of the different letters. Here in our host city of Delhi, there are 5 root servers. In Hyderabad, there are 2 root servers, one for E and one for F. In Kolkata, there are 2, one L root instance and one J root instance. So the first metro I showed was Mumbai, and given all the landing stations there, of course, they have many root servers. But as everyone here knows, Chennai also has quite a lot of submarine cable landing there. So it's no surprise to see that Chennai has 3 root servers. And it's also very nice to see Bengaluru here, a city of 8 million people, also has a root server. But Bengaluru, perhaps, is actually a really good case study. It's a city of 8 million people, and it has 1 root server instance. And then it's not just the city of Bengaluru, it's all the outlying areas. And so I think if we were to measure the telemetry of DNS queries in Bengaluru, what would the round trip time be to the root server? And then think about that, because what would it be like in some of the other, sorry, I've lost my cursor here. What would it be like in some of the major cities all throughout India that don't have root service? What is it like in Puri? What is it like in Ahmedabad? There are no root servers. There's no root service anywhere near there. The 7 metropolitan areas, the 6 that I mentioned, and also Pune gets good coverage from Mumbai, have about 72 million people. According to the World Bank, and I'm not quite sure how they measure this, but according to the World Bank, there are about 470 million internet users in India. I think that might be a bit low. I'm not sure how they're calculating all the many hundreds of millions of mobile users. But there's a lot of internet users in India, no surprise, yeah? And yet we only have root server coverage from a metropolitan perspective for about 72 million of them. And if we think about internet topology, if we think about how we connect networks to networks, how networks inside a metropolitan area, how many fiber miles, how many route miles that we need to connect metros, internet networks in other metros, I think maybe we see a challenge is we need a lot more root server instances. I think that when you think about an internet exchange point, a very important point of peering and interconnection, I think every one of them needs a root server instance. I think any service provider listening to me right now, if you don't have an authoritative server inside your network, you need to ask for one. Because the good news is these are free. They come at no cost. You can ask any of the root server operators. You can ask ICANN that operates LRoot. And you can simply email us and say, hey, look, this is our organization. We run a network here in this city or in these cities, and we'd like a root server instance. And we'll send you a box that to just plug in to the rack, and we'll send you configuration instructions that are very straightforward. And all of a sudden, all of your users inside your network have a root server instance inside of your autonomous system. And we need many more service providers, many more enterprises, many more universities to have root service locally so that it's available to their users with a short round trip time and with a high amount of reliability. For the internet exchange points, if anyone here is operating or wishes to operate internet exchange points in the future, I think it's also very important that we have authoritative servers there. We have authoritative servers for the root, we have authoritative servers for .in, and we have authoritative servers for other things that the members of the internet exchange point find important. And there are many root server operators, E and F and J and K, who regularly provide no-cost root servers that they ship out to the exchange point operators for inclusion into the peering lane. So let's talk just a little bit about governance. Earlier we discussed this story about J, K, L, and M, and the problem was John Postel died after M was assigned to wide, and before J from VeriSign and L from ICANN could be assigned out to new root server operators. And ever since John has died, we've had no process to add or replace root server operators. So it's been now more than 20 years since John Postel's death, and for the first time we have a path forward. This root server system advisory committee that I just talked about with the statistics has created this paper called the Proposed Governance of the DNS Root Server System. And they've worked very hard to get it right, and in it, it has the first steps that we need to add new root server operators, to replace existing root server operators, or if necessary, to remove a root server operator. It has quite a lot to it. It has a secretariat function. It envisions a strategic and architecture and a policy function, monitoring and measurement, and very importantly, it actually has a financial function. Because it turns out you actually never get paid directly for running a root server. If you're a root server operator, ICANN is a root server operator. We have hundreds of instances, and we'll send instances to any service provider organization. Ask for one, we'll give it to you. But that comes at a cost. And actually, it comes at a fairly high cost. And ICANN doesn't get paid by anybody to run a root server. We do it because we think it's a good idea for the internet. And actually, all of these 12 root server operators think it's a good idea. It's necessary for the internet, for its growth and for its sustainability. This new governance model actually includes good ways of making sure that all of these root servers are financially stable. Very important. But I wanted to talk just a little bit in the context of our discussion about designation and removal. This new governance model establishes when there is a need for a new root server operator. And it's where I'm going to pause just a little bit and say, you know, we've actually never identified a technical need for a new root server operator. We have some very large countries that don't operate their own letter, their own root server letter. There are many instances. We have 20 instances here in India. We need more. India does not operate its own root server letter. And you know what? It turns out that's okay because technically there's no need to. Technically what is important is that we have instances of all the letters everywhere here in the country. Everywhere where it topologically makes sense, where networks interconnect, that's where we need an instance. And the label, the letter A, B, C, D, it does not matter. What matters is that there's a root server, because that's how the end users resolve their queries. So we have a new governance model that we hope to implement soon that will establish when there is a need. But so far, since our history going back to 1983, 36 years, there's been no need for a new root server. If there is a need, we can go obtain applications from organizations willing to serve as root server operators. We can evaluate these candidates by objective measurements. We can recommend who should be a new root server operator. Importantly, we can handle removal cases where perhaps it's time for a root server operator to be replaced. Importantly, we can participate in accountability efforts to evaluate existing operators for compliance with policies and metrics. Just very briefly, the current status of this proposal is a paper has been published. It's found on the ICANN website, and there's a public comment period open right now. Will close in a few months. So let's go back to the technical talk for a little bit and talk about how the root zone is distributed, because this is where it gets kind of interesting. In the traditional model, we have this function called the root zone maintainer. The root zone maintainer is actually a contracted function. Anybody can be the root zone maintainer. And currently, it's actually VeriSign. And what VeriSign has done is build a very strong and very redundant distribution system where changes happen to the root zone that are provisioned through the IANA to ensure that all the changes are authorized. And then it's put together by the root zone maintainer into a final edit of what is the root zone file every day. And through a very redundant structure, it's distributed to each of the root servers, A through M. It actually turns out, though, if you look at the history of DNS resolution over the last 20 years, a small number of very, very large recursive resolver operators actually choose not to run their service through the root. They actually run a local copy of the root on their own recursive resolver. Steve Crocker, the author of RFC1 50 years ago, actually named this concept. He called it hyperlocal, an extremely local copy of the root running on the same server as your recursive resolver. Hyperlocal is not meant to replace the root server system. It's simply meant to complement it, to get some technical benefits of running it very locally instead of relying on any of the root server operators and their instances which are outside of your network. The IETF took a look at this and they decided, you know, it'd actually be a very good idea if we were to document what hyperlocal is. That way, if anyone wants to run it, they can do so safely and they can do so properly with a good base of reference. So the current internet draft is RFC 7706biz. It was revised this past March. And importantly, if you read the RFC, it gives good examples on how to set up hyperlocal functionality inside your recursive resolver. Hyperlocal is good because for your users, it's fast. It's very, very fast. It's on the same machine as the recursive resolver. So the round trip time is essentially 0. Importantly, for security and for privacy, it's local. So queries for root information that all of your end users make, they stay private because they cannot be misrouted. And then because it's local, you cannot snoop on the queries if you're not already inside the network. You can't look on the wire between your users and the root servers for these queries. However, it's important to note that if you open up a DNS recursive resolver right now, straight out of the box, and you just prime the server with root server information, it all works. It all works very well. It's got 36 years of history working. If you set up hyperlocal, you're adding some fragility, right? Because now you're setting it up, okay, I have all my queries, use my hyperlocal root instance. However, if for some reason that's not available, let's ensure we have a fallback to the root. So there is a little bit of fragility there. So to finish up today, I just want to harp on 4 points, please. It's that the root server system has been around for a very long time, since 1985. It is strong, it's robust, and it's redundant. It has very much worked. But here in India, we really need more root server coverage. We need better coverage with instances of every current and every future internet exchange and instances located at many more points of presence throughout the country. The internet itself, it always evolves, yes? We always have new technologies, we always have new things, and as the internet evolves, we're hoping through this new governance model that so too will the system of root service, and this new governance model we hope is a valuable and significant contributor to that. And so that's a brief history of the root server system and a little bit of a look at root service here in India. I hope that was useful for you. Thank you.
Thanks, David. Any questions for David? You can proceed to the microphone, please.
David, thank you very much for a very nice history, which will be authentic coming from you. One of the things you mentioned that you do not have data of G root server. So is it good or is it not so good is number one. And second is, if we have, let us say, more root instances and routing is not good, for example, if there are 7 instances in Mumbai, still they are not well connected, a query could still go out of that. So would you like to comment on this? Thank you.
Sure. So you bring up a good point about groot. And one of the things that we hope the new governance model can help us improve is providing baseline measurements to evaluate an existing root server operator. groot does not publish statistics right now. We don't know how much data that they're processing every day, how many queries. We don't know anything about it. And sometimes they actually don't show up to meetings. And now, is this good or bad? Well, I don't know. But we have a new governance model that will be able to measure this objectively with all the other root server operators and with the baseline of service that we desire. And what's nice about it is if we decide, if these measurements show you in objective terms that the operators of groot are not doing a good job, just objectively, then now we, for the very first time, we have a way to replace them as a root server operator. And that's the truth. The connectedness, I mean, you've hit the nail on the head, Rajesh. We need more root server instances because the state of connectivity isn't all that good. It's not good enough, not for the number of users that we have. The growth in India, you and I were talking about this earlier, the growth in India is spectacular. The growth in India is just exponential of exponential. And it's very hard as a network operator to prepare for that. It's very hard to service that. Because it's one thing to go from 100,000 users to 1 million users, but it's a very different thing to go from 100,000 users to 10 million or 20 million, or for the mobile operators to 300 million, right? And so connectivity takes time because fiber is a hard thing. You have to roll it, you have to plant it, you have to light it up, and all of this takes many months and sometimes many years. And so it's so important that in every autonomous system, every service provider infrastructure, every enterprise infrastructure, every university infrastructure, anyone who runs a network of any significance really needs to think about, I should probably have a root server there. Because that's what allows the end users to ensure that they have a reliable path to a root server and reliable resolution for all of their DNS queries, which, you know, our users don't know anything about this, right? Our users can't tell us what a recursive resolver is. They don't know what a root server is or an authoritative resolver is. They count on us as the network operator. They count on us, the people who they pay, where they get their internet service from. They expect that DNS will just work. But you and I know it's actually a lot harder than that. One of the ways we can make it easier on ourselves to provide good service to our end users is to have root inside from a root server instance or a hyperlocal instance.
While there's another question would come, is that technically we could have a measure of saying that for our more than 600 million users, and for how many users we need one instance?
So the truth is the number of users is probably not a very good measure. We have to think about this topologically. We have to do studies. It would be very good, it would be very useful if we were able to study the telemetry of root server queries at each of the interesting points of presence around India. And where we see a round trip time that is too long, that we think takes too long, that's where we need a root server. It's easy to say we need a root server at any internet exchange because topologically it makes the most sense. It's where all this peering happens. It's where you get the Netflix. It's where you get the Facebook and the Twitter and all of that. That's where how the content gets to the eyeballs is at the internet exchange. So it's very easy to say, look, if there's an internet exchange, you should have an authoritative server. After that, though, it gets a little bit harder it gets a little bit more abstract. And there is where we have to really do some measurements and really think about where are the most important points of presence, the most important points of interconnect, so that we can put the root servers, the authoritative servers for .in, these types of things, where we can put important infrastructure, NTP servers, all these public NTP servers, important things where we can put at important points of presence. This requires work. This requires effort.
Thanks.
Hi, Vivin from DKIX. My query is a very simple one. We run an exchange in Mumbai, Delhi, a couple of other locations as well, and globally as well. You do represent the ICANN root servers, right? Do you guys peer in any exchanges in India as of now?
So, I
Answer
couldn't hear
is
the
in-
very last part of your question. Do we peer what?
My question is that, I mean, I'll actually ask is better. Why is ICANN is not peering with any internet exchanges in India as of now?
So we don't, so as a content network, as a network, we don't
No,
actually,
as a DNS.
oh, so from the L route.
Yeah, yeah.
So you have to ask.
Sorry, so I'm
Yeah.
someone who worked with the folks in WebWorks when I was
Yes.
working with them to have an instance in Mumbai. The answer I got from ICANN was that we don't peer in internet exchanges.
Okay.
So if the policy have changed,
Okay, so-
there is a couple of guys from Xstream, the technical team of multiple exchanges over here, so we love to peer with or have you guys in the exchange as well.
Yeah. So ICANN will provide an L root instance to any corporate organization, an official corporation recognized by the state. We'll provide an L root instance. However, we've made a technical decision for L root not to be at internet exchange points. But that's okay, because our friends at eRoot and froot, kroot, jroot make it just as easy. You can ask Packet Clearinghouse, you can ask Bill Woodcock, send him a quick email and say, look, we have this exchange point, we'd really love authoritative, and he sends you one right away.
Interestingly, everyone is already peering. So
Yeah.
that's a query was like
Yeah.
when you mentioned that the internet exchanges should have an
Yes.
exchange. I mean when someone represent an organization and tell that you guys should do this more, everyone else is doing, while probably I can also do the same thing, right? I mean
Yes.
just a query. I mean just a
Yes,
suggestion.
I agree with you, my friend.
Thank you.
Yeah. Mr. Anupam.
Hi, Anupam from ISOC Calcutta. So you mentioned about RSAC 037
Yes.
and RSAC 038 is about the recommendation to the board.
Yes.
So what has actually happened with 038?
So 037 and 038, if we think about it just in the picture, in the context of the whole root server system, it's essentially the same thing, okay? 37 has the technical details.
Right.
Where 38 is more of a procedural thing within ICANN's policy development process.
Mm-hmm.
Where we're at today is we have an open public comment period, open for quite a few weeks, quite a few months actually, where the public is now invited to comment on the specifics of how the governance would happen, these different secretariats, these different functions.
So are you saying the board is still to look at it and it will be done only once the public comments is over?
When the public comments are done, the staff will present the report of the public comments to the board, and if it's generally positive, our expectation is the board will ratify RSAC 37, which will then allow the governance model to go into place.
So it is now just a recommendation.
Yeah.
Okay.
I think we're at the point now where this concept paper is complete. The public now has its opportunity to comment, and in the absence of a lot of negative lack of support, in the absence of that, I think we are fairly confident the ICANN board will be ready to ratify this in the coming months.
Okay, thank you.
Thank you. Thanks, David.
Thanks, Anurag.